Let's tackle the example problems from lesson 5.2. In the first example, we are finding the variables E, F, G, and H, and those variables represent the four angles in this quadrilateral here. So right now we don't know very much in terms of the quadrilateral, but we have some other things around it. And so here's what I'm noticing. I'm noticing that I have a pentagon, and it is an equiangular pentagon. And so to find the measure of one interior angle, I'm going to go ahead and take my pentagon sum, which is 540, and I'm going to divide by 5. And so I know each of those angles is 108. And you could, have just gotten that from the chart above, but I just wanted to be explicit about what was happening there. So then to get E, I would use my linear pair conjecture, and then go ahead and take 180 minus 108, and that means E is 72. So that's E. For finding G, so this angle here from the pentagon is 108. Then I notice I have another equiangular polygon, and this polygon here has 8 sides and 8 angles, so it's an octagon. So let's just remember what our polygon sum formula is. It's 180 times n minus 2, and then we're going to divide that by 8, or n. And I'm going to go ahead and substitute 8 in for n here. So the total number of degrees in an octagon is 180 times 6, because 8 minus 2 is 6. So it's 1080 divided by 8, which turns out to be 135. So one of these angles is 135, so I can put that in here. Therefore, to find angle G, if you notice, G then makes a full 360-degree circle with that 108 and that 135. So to find G, I'm going to do 360 minus the 108 minus the 135. And that gives me G is 117. To find F, I get to use linear pair conjecture again, but I've already done the hard work, right? I already found the interior angle of that octagon. So then I'm just going to do 180 minus 135. So F is 45 degrees. Go ahead and erase this here. And then how am I going to get H? Well, I have a quadrilateral. That quadrilateral always sums to 360 inside. I know E, I know G, I know F. And so to get H, I'm therefore just going to take 360 and subtract my E, my F, and my G. And I get 126. So that was the first one. Now for the second one, I'm noticing that I have a bunch of exterior angles given to me, but not all of them. I also noticed that 3 of the exterior angles are congruent, and I want to find B, which is the measure of one of those exterior congruent angles. So I'm automatically thinking exterior angle conjecture. And in this case, we know that the exterior angles always sum to 360 degrees. I'm going to go ahead and write a nice little equation here. But first, so I have this exterior angle is 69 and this exterior angle is 43, but I don't have this one. So I get to use my linear pair conjecture, 180 minus 68. That is 112. And since this angle B is congruent to this angle and congruent to this angle, I can then write 3B plus my remaining exterior angles as a total of 360. I'm going to go ahead and just combine my like terms. (3b) plus 224 is 360. Go ahead and solve that for b by doing inverse operations. 3b is 136, and then b itself is a decimal. It's 45.3 repeating, which is 45 1/3. If you want to go ahead and write that as 0.3 repeating or as 1/3, that's fine. This is a bit of an awkward value to check, but here's how you could check it. You could find this interior angle here by doing a linear pair conjecture and then finding all the other missing interior angles and then double checking that they sum to the correct value of a 1, 2, 3, 4, 5, 6 hexagon. Always good to be able to check your answers. Okay, finally, how many sides does a regular polygon have if each exterior angle measures 45 degrees? So we're looking for how many sides, which is n, and I know that any regular polygon has has an exterior sum of 345 degrees, or 360. Yikes. But if it's a regular polygon, each of those exterior angles are the same, so I can go ahead and set up this equation. The total exterior degrees, 360, divided by the number of sides, aka the number of angles, has to be 45. So I could set up this equation. There's a couple other things you could do as well. If each exterior angle measures 145, then each interior angle has to make a linear pair with that. And so that has to be 135. And so then you could use your polygon sum formula, 180 times n minus 2 divided by n. This is your polygon sum formula divided by n. That's giving you the interior angle. And that could be 135. So you could solve that. So whichever one feels better to you. I'm going to go back to this one, actually. I think it's the most efficient. To solve this equation, you're going to actually have to multiply both sides by n first. The n is in the denominator. That gives us 360 is 45n. And then go ahead and divide by 45. And we should end up with n is 8. And I know that because if we went back up to example 1, I ended up with an interior angle of 135 in a regular octagon. And when I looked at this equation, that kind of gave it away to me. It's always good, though, to be able to do an example and make sure you understand how to do it in case you got a question that was like this, but of course not with an octagon, something you might maybe have remembered from before. So these are some example problems of when we use the exterior angle conjecture as well as the equiangular conjecture. So great job.